In the previous video, we have started creating our player avatar, so now we can look around using our Cinemachine camera. And now I would like to add also the possibility to move our character around as well as to communicate with other scripts. So let's stop our game and let's add new scripts to our player folder inside our scripts folder. So I will want to right click, create a new C# script. And first of all, I will want to create a script called character. Okay, let's open this script up in Visual Studio. Okay. So again, I will paste the script here so that we can talk about what is going on here. So our character script will be a high-level script that connects all the functionality of our character with the other parts of our game. And for now, its task will be to control the input and get the input and pass it to a specific class responsible for the player movement. So we are going to have at the top serialized field private camera, main camera reference. This will be useful when we want to implement our digging mechanic so that we can detect where we have clicked. Next, we're going to have a serialized field private player input. This is the script that we have created in the previous video. Next, we are going to have a serialized field private player movement. So basically, the idea is that our character is a high-level script. It will pass the value from the player input to the player movement, and the player movement script will be responsible for actually moving our character. We are going to soon implement the digging mechanic, so we have public float interaction ray length. You don't have to type it right now. We're going to also have public layer mask, ground mask. Again, this will be for the future video about the digging mechanic. And we are going to have next public bool fly. This is a bool flag. If we are flying or not, it is set to be false. Next, we are going to have public animator. So this is the reference to our animator. We could probably have it in a separate class. It will be used to call our animations. And next we have bool is waiting equals false. This will be useful when we call our jump animation. We will want to wait a bit before we can again call our jump animation. Next, we're going to have awake method. And in the awake, first of all, we want to access the main camera. We are going to find the camera.main. So the camera needs to have the main camera tag on it, so it will work. Next, we have player input, get component player input, and player movement, get component player movement. We are going to create this script next. We have the start method, and in start, we want to assign to our player input on mouse click, candle mouse click method. You can right click quick actions and generate this method. And we are going to have player input on fly, candle fly click. And again, right click quick actions and generate this method. In the handle fly click, we are going to set the bool flag to the opposite value, so from true to false, from false to true, and this will always work if we press our V key, so we can disable and enable flying mode. Next, we're going to have the update method. And basically, we're going to check if we are in the fly state, so we want to fly, or if we are in the basic state, so we want to walk and jump. So in the fly, we want to set animator.setFloat speed to be 0, animator setBool is grounded to be false, and animator reset trigger jump. And make sure that you type those correctly because we have those from our imported character. If we go to our animated character medium and select the animator window, you will see in the parameters that we have the speed, the jump, and is grounded bool flag. Jump is a trigger and speed is a float value, and all of those transitions between the animations are set using those values. We will want to drive those through our script. So in the fly, we want to set the float speed to 0, is grounded to false, and jump to be reset. And we are going to call player movement.fly, and this method inside our player movement script will be responsible for flying mechanic. So here we are going to pass to the fly a player input.movement input, so the vector 3 about the movement input. Player input is jumping, bool flag, so we know if we want to jump, in this case it will rise as higher, and we want to pass player input.running pressed, so the shift key, if we are pressing the shift key, we are going to descend And of course, we are going to simply move around, so fly around using our movement input. Now, if we are not flying, we are going to set our animator.setBall is grounded, and we are not going to use the characters controller inbuilt is grounded, but we are going to create our own code since I found the character controller grounded bull flag pretty unreliable, but this is just for the matter of simplicity. So player movement is grounded will have the value if the character is grounded or if it is jumping. Next, we're going to have if player movement is grounded and player input is jumping and is waiting is false. Is waiting is a bull flag that we have created above. So if those conditions are true, then we simply want to set the animator set trigger jump is waiting to true, stop all coroutines, and we want to start a coroutine called reset waiting. And the reset waiting is enumerator reset waiting. It is just yield return new wait 4 seconds 0.1 of a second. We are going to call animator reset trigger jump, and we are going to set is waiting to false. So this will prevent our jump animation being played a couple of times because we have set the trigger jump to be true after we have already started playing the jump animation. Next, we're going to call animator.setFloat, and we want to always set the speed float to the player input.movement input.magnitude, since this doesn't influence how fast we are playing the animation, but rather if we are playing the movement animation or not. And at the end, we have the main functions that will handle our movement. Player movement.handle gravity, so it will apply the gravity and move our player according to if player is jumping. So we are passing to it a player input.is jumping. And on the next line, we are calling player movement.walk, and it will handle the movement itself. So how we traverse our map, and it will be player input.movement input as the first parameter. So this is the vector 3. And the second parameter is bull flag running pressed. So we know if we want to start moving faster or not. Okay, it was a lot of code. We could have extracted it into separate methods, and probably we should have. But basically this will work. And at the bottom here we have our reset waiting. We have discussed this, and handle mouse click that we are going to implement soon. So we have the character. Let's save it. And now what remains is our player movement script. So let's copy the name and let's go back to Unity to create this script. Great. Now we can see the error, so we do not have the player movement script. Right click, create a new C# script, and let's paste the player movement name, and let's open the script up in Visual Studio. Great. Again, I will paste the code here that we are going to have. So player movement will be responsible, so the script will be responsible for moving our character, so basically affecting the character controller component that we use as a base for our movement system. So we have the serialized field private character controller, the controller reference. Next we have few values that we are going to use for our movement, so player speed equals 0.5, this is the private float. Player run speed, it will be equal to 8. And I want to serialize those fields so that we have this exposed, so we can set those through the inspector. Jump height 1, gravity value minus 9.81. This will be, we will need to apply our gravity manually to our controller since this is not using the rigid body physics. And next we have private float fly speed. Fly speed in fact will be the speed of the ascent and descent that we want to have. So how far we are moving up or down when we are flying. Next we have a private vector 3 player velocity, and this will be important in our calculation to collect how we want to apply our force onto our character controller. Next, as I have mentioned, we are going to use our custom code for checking if we are grounded or not. So this will be serialized field layer mask ground mask. Next, float ray distance, and this will be 1. But we are going to modify it through the inspector, so this needs to be serialized field or a public variable. And at the end, we are going to have a serialized field public bool, so this is property, and this is called is grounded. Get is public, but setter is private. And to expose it, we can use in Unity 2020 in Visual Studio 2019, field colon serialized field to expose it so that we can see it in the inspector. Great. Now, first in the awake, we are going to get the reference to our character controller. So controller equals getComponent character controller. Next, we have getMovementDirection helper method, private vector3 getMovementDirection, and we are going to get in a vector3 the movement input from our player input, and we are going to return transform.right. So this is the right, the red arrow of our character model, times the vector movement input.x. So this is the movement in the horizontal direction, and the transform forward times movement input.z. This is the forward or backwards direction. So this is how we are going to get the correct vector of the movement for our current model. So this is why we are using the transform.right and transform.forward. And next we have, of course, those methods that we had inside our character script. This is the fly and walk and handle gravity. So first we have the public void fly. It takes vector3 movement input. You can create it by going to character, selecting where you had this method used. So when you are in the update, you can right-click quick actions and generate it, so you do not have to type it all. And you can do the same for our handle gravity and walk methods. So when you are done, go back to player movement, and those methods should be automatically created. And we are going to have fly vector3 movement input, bool ascend input, and bool descend input. Those were jump and run input, respectively. Now next we are going to get the movement direction by calling our getMovementDirection by passing the movement input. Next, if we want to ascend, we want to call movement direction plus equals vector3 dot up times fly speed, and this is the spacebar or jump input, and we do not want to do both. If we want to ascend, this is prioritized. If we want to descend, we are clicking our shift button. We are going to decrease the movement direction by vector3.up times fly speed. So basically this creates a vector from this value and applies it onto our movement direction. And at the end we are going to call controller. So this is our character controller dot move method, which supplies the parameters for the movement of our character controller component. And we are going to pass our movement direction times the player speed times time.the time, and this basically moves our character controller. Now, since we are using this in the update of our character script, we are going to move it every frame. Next, we have the public void walk, which takes vector3 movement input and bool running input. All we need to do here is again get the movement direction by calling getMovementDirection, passing the movement input. And when we have this vector3, we are going to calculate the speed using the ternary operator running input question mark. So if the running input is true, we are going to return the player run speed. If we do not want to run, colon player speed. So this is the basic speed, I think 5, and the run speed is 8. I could have named it a bit better. And at the end, again, we want to call controller.move, and we want to move the controller in this direction. Now this happens when we are pressing the arrows up, down, left or right. But what happens if we press the spacebar? Well, our public void handle gravity that takes bool is jumping handles this logic. So basically we constantly want to apply the gravity value onto our character controller. And we're going to first check if controller is grounded and player velocity.y is less than 0. We want to reset the player velocity to be 0, so we do not have some glitching of our player falling through the terrain. Next, we want to check if jumping is true and we are grounded. Only then we want to apply the jump force. So basically we want to jump. So add jump force, and you can right-click quick actions and generate this method. And in this method, all we need to do is set the player velocity.y equals the jump height. Next, we have the apply gravity force method. And in here, we want to simply apply our gravity value, so minus 9.81. We want to apply it over time onto our player velocity.y value. Again, player velocity is a vector3 that we are collectively creating by applying different forces. And next, we want to make sure that we clamp this y value to the gravity value, and I think I have used 10 for the max value. So basically, this is the maximum value with which we can be going upwards. Okay, so we have applied our gravity, added the jump force. All we need to do is call our controller in the handle gravity, dot move, and use the player velocity that we have created. So this is the value that we have created, times time.delta time. Now we needed this vector 3 because move method takes the vector 3 motion vector. But we are basically changing only the y value and controlling the clamping it so that it doesn't go outside of the bounds of what we want to have in our game. So we have the add jump force, add gravity, and last thing is the is grounded in the update method of the player movement. So is grounded is equal to physics.raycast, and we are going to pass the transform.position as the start of the raycast, vector3.down as the direction, ray distance, which is the distance of our raycast, and ground mask as the ground mask to detect our is grounded. And last thing is our onDraw gizmos, so we can call gizmo.drawRay, transform.position vector3.down times the ray distance, so that we can visualize the raycast and adjust the length of it. Okay, with all this code written, again you can verify it using the GitHub repository. Let's save it and let's go back to Unity. Great, so now all the issues should be gone. Let's select our animated player raw. Let's make sure that we select overrides and apply all, and let's open this prefab since we want this all the code to be saved on our prefab. So let's select our player movement and let's assign it onto our animated player raw. And we have, I don't think that we have our layer or ground mask set. No, we don't have a ground layer mask, so we are going to leave it. The controller will be accessed automatically. The parameters should be good, although I think the jump height should be set about 3. And we have the ray distance. So what we can do is look at our player. So make sure that you have gizmos on. And as you can see, for one, it is going pretty far downwards. So let's decrease this raycast. Let's maybe select the z-axis, and I think this kind of length 0.11, 0.12 should be good enough for our player. Okay, so now we are going to only detect if we are grounded if our raycast is shooting at the ground. Okay, last thing that we are going to add to our animated player raw is a character component. Let's minimize the capsule collider, character controller, player input, and player movement. And now we can assign, the main camera will be assigned automatically, but we can assign it through our scene, through the hierarchy. Let's assign our player input, let's assign our player movement, and the ground mask again, we will need to set it up. And this should be it, although we need to have the animator, so let's assign our character medium. Great, so now this is it. Let's save this prefab using this arrow and save. And of course, we can assign our main camera. And make sure that you go to our layers in the top right corner of Unity, edit, select layers, create ground. Okay, let's select our plane. Let's select the layer and let's set it to be ground. Now we can select our Kenny assets, the animated player raw, and let's set in the character, the ground mask is ground. And the player movement, I think it was ground mask, set it to be ground. And now those settings will be saved in your prefab. Okay, so I think we're done. Let's click play. And I'm going to zoom out in our scene view. And as you can see, we can now rotate and we can start moving, and the animations should be played. So we can go to the left, to the right. And as you can see, the animations are not great because we do not have those animations for the left and right movement. But basically, we can jump, pressing the space bar, and we can move around, and we can move and jump. So it should all be working. So we have our test character created. Let's save the scene. Let's go back to our original scene, the voxel world. And we are going to basically add the cinema machine and virtual camera. And now what we can do is go back to our, let's save the scene, let's go back to player test, let's select our vcam, let's copy the parameters using these 3 dots by selecting the CMVCam1. Copy the component. Let's go back to voxel world and let's paste those. Okay, and we should have paste component values. And we are going to remove the follow component because we cannot really create it until we have our ground. And let me just check the CMVCam1, and I don't think all the settings were copied, so let's select the body and let's select hard lock on to target and aim same as follow target. Another thing that we are going to have to do is go to our assets, select our chunk and make sure that the chunk is set to be on the ground layer. Let's go back. Okay. Great, so just one more thing that we need to do is select our animated player raw and make sure that the jump height is set to be 5, not 3. Okay, so now if we press play and try to generating our terrain, we can drag our animated player raw somewhere inside our map. When you drag it onto your map, it should stick on the surface. Let's select our CMVCam1. We could put the chunks inside a separate game object so they do not clutter the hierarchy, but we can take care of it later. For now, let's select our camera, let's select the follow, and let's select our eyes of the character. Okay, and as you can see, success, we can see our world from the perspective of our player. So now we can move around, we can jump, and this is why we needed to increase the jump height, because we can barely jump on top of each of the new layer of the blocks, and this should all work fine. Now in the next video, we are going to start working on a game manager script that will allow us to spawn the player onto our map, and it will be partly responsible for calculating if our player is going further from our starting point, so that we can know when we want to generate new chunks in front of our player and remove the old chunks from the other direction so that we can reuse those and save some memory. Okay, this is what we are going to start working on in the next video. See you there!